All right, today we're talking about dividing whole numbers. Today we're talking about dividing whole numbers and fractions in the textbook 3.5, page 129 for the grade 8s. So you remember way back you were in grade 3 and you started to learn to multiply and divide, and the teacher would say something to you like, well, you have 20 cookies and there's 5 kids. How many cookies does each kid get? And then she'd probably put some rings on the table like this, and you would take those little cookies and you would divide them up, and you would soon learn that if you divide them evenly, that each kid is going to get 4 cookies. Well, we're kind of going back to our roots with that and getting the visual models. But first we're going to look at this. It says, work with a partner, you'll need scissors, your teacher is going to give you a large copy of these. No, I'm totally not. But I made little copies of these right here. It says, square A models a whole number 1. So here we have, I'll put them on my board. Here I've got a whole. So that is a whole. Figure B represents 3/4 of a whole. So do you see how that's 3/4 of a whole? Just nod your head and go, if it does. Says, use one copy of the diagram. Find 2 divided by 1/4, because C is now 2. So here we go. This is going to be fairly simple for you. Please call it out, grade 8s. What is 2 divided by 1/4?
Well, 8.
8. Now, how did you get that?
Well, I mean, 2 times 4 times.
Yeah, you got the 4 quarters, right? So if I took my scissors and actually divided these up into quarters, I would have 1, 2, 3, 4, 5, 6, 7, 8 quarters. Pretty easy peasy. But then it says, can we find 2 divided into 3/4? So if I start using my little manipulative here, I've got 2, and I'm going to put them right beside each other. So I could go like this. I've got 3/4 here. I covered that. You can see 3/4. I could cover another one like this, and that's now 2 of them. Can I do it again? I can't. At this point, I have a remainder. Now this is just like in grade 3. If I gave you 21 cookies and said there's 5 kids, how many do each get? You say, well, everyone gets 4, but then there's some left over. So I mean, I could say that 2 divided by 3/4 equals 2 with a remainder of 1/2. But I could do it differently, couldn't I? How much of this shape fits in there? 1/2 of this shape fits in there? 2/3 of this shape fits in there, doesn't it? So if I divide this, I get 2 and 2/3. Now I'm going to show you that again. Watch. I can fit one of them in there. I'm going to turn it. I can fit 2 of them in there. And I can also fit 2/3 in there. So the answer is, how many 3/4 fit in 2? 1, 2 of them, and 2/3 of 3/4 fit in that shape. Now that looks a little complicated. Don't worry, we're going to revisit again. We're going to go into, I think it's question number 4, which addresses this exact issue. Let's take a look at the next example. How many of you hate number lines? How many of you once hated number lines, but they are no longer your enemy? In some cases. Well, yeah, in some cases. I like the honesty. All right. Here it says we can use a number line to divide a whole number by a fraction. To find how many thirds are in 6. So here, this problem that we're working on, I'll just get my manipulatives off the board. This is 6 divided by 1/3. That's where we're going with this. 6 divided by 1/3. So what this means is how many thirds are in 6? So if I take a look, I'm going to actually put this a little closer up to my camera that I'm shooting the video, and then I'll pause it and show the class. They've actually taken a timeline, a number line that has 6 holes, and they've made thirds. 1, 2, 3, 4, 5, 6, all the way up to 6. And then you can see that there's 18 1/3 size jumps to get to 6. So to review what we just went over in class, I'll just say it again, but I'm going to say it for the recording camera. We looked at a second example and we said, what if we took 6 and divided it into 2/3? So here we have 2/3, and we're jumping 2/3, 2/3, 2/3, and once again we can see how many jumps it gets to 6, and that was 9 jumps. But what if it doesn't fit perfectly? What if we have a remainder like we did before? So let's take a look at an example of a remainder like we did before. And I'm going to try to adjust these cameras so that they're consistent with each other, because I know we're having a discrepancy between them. So let's take a look at this number. We're going to see how many times 4/3 fits into 6, or 6 divided by 4/3. As you see, it doesn't quite fit. We end up with a tiny bit left over. We have 1, 2, 3, 4 jumps, but then there's only 2/3, not 4/3. Now I'm going to pause the video. We're going to go over this one as a group. Wow, this video is getting all over the place. Looks like we're starting it on the board now, but we did a few examples in class, and I figured we needed to up our skill level on this. So we started talking about on page 130, halfway down. I don't know if this is going to be very clear in the camera here, but this example right here, it says 6 divided by 4/3. So I want to show you a couple ways to do this. So we have 6 divided by 4/3, and I'm just going to see if this is hitting the camera, right? Yeah, it looks like it. So I'm going to start with a number line. 1, 2, 3, 4, 5, 6. That's 0. That's 6. 1, 2, 3, 4, 5.
Just a reminder, it's 5-6 track practice right now, please, and if you are part of the track team, you should be here. Thank you.
So we're seeing how many jumps of 4/3 we get in 6. Now the example I gave the class was, I have a frog. Every time he jumps 4/3 of a tile, or 1 tile plus a third. So he jumps 4/3, 1, 2, 3, 4, 4/3, 1, 2, 3, 4, 4/3, 4/3 again, and then he jumps that 4/3. Well, we noticed that this is 2/3 left. So I said, well, we got 1, 2, 3, 4 jumps, and I said to the students, which answer is correct? Now, if you're watching this video and just following along the instruction, I would advise, literally pause the video, and I want you to ask yourself, this one or this one? Because it's actually kind of surprising what the result is. I'm going to presume you pause now, and I'm going to go forward. A lot of kids are going to say this one, but this is the proper answer. Now, I'm going to show symbolically how we do this, and we're going to come back. But first, I want to ask you this. If the frog is jumping, how many jumps? 1, 2, 3, 4. Did he do 2/3 of a jump? Or did he do half of a jump? So that should already clue you in as to why this might be the right answer. But first I'm going to show you symbolically how this works. We have 6 divided by 4/3. Now before I go forward, I asked the kids what's the relationship between multiplication and division. The relationship is they're the inverse or the opposite of each other. They're the flip of each other. I'm going to rewrite 6 as 6 over 1. So what I need to do is I need to flip one of these numbers, multiply them, get an answer, and flip it back. I'm going to show you what that looks like. I'm going to flip this number to 1 over 6. And now, because I'm doing the opposite, I have also flipped the symbol to the opposite. I'm going to flip, multiply, get an answer, and flip back. 1 times 4 is 4. 3 times 6 is 18. I flipped, I multiplied, I flipped back. That is my answer. If I simplify that, I'm going to get 4 and 2 over 4, or 4 and 1 half. Now what I did there is, I took my 6, made it 6 over 1, same. I flipped it, multiplied, flipped it back, and simplified. Now, why is it 4 and a half? Because you might be saying, Mr. Ewart, it still makes no sense. Clearly, I see 1, 2, 3, 4 jumps, and there's 2/3 remaining. But that's not 2/3 of the frog's jump. That is 1/2 of the frog's jump, because a frog's jump is 4 over 6, or 4/3, and 2/3 is exactly half of 4/3. Now, if you're still not getting it, don't worry, we're all good. We're going to look at another couple of examples. And if you're still not getting it, watch the video again. Go check out the Math Antics guide, or talk to me in class. Let's look at number 4 in the book. It says, use fraction circles to find 4 divided by 5/6. Oops, I should write that a little better. No, I'm going to do this a number of different ways. It says use circles. All right, I'm going to use circles. Here it is. 6. And I've got 5/6. Like this. 1, 2, 3, 4 pieces left. Well, this is where he's probably going to say, well, that's 4. And then I've got 4/6 left. But it isn't 4/6. If I have pieces like this, 1, 2, 3, 4, each piece is literally 5/6. And if 4 of those are covered, 4 out of 5 of those pieces are covered. Your answer is 4 and 5/6. I'll illustrate that a couple different ways, just to make it a little more obvious to you. Let's go to the number line. I have 1, 2, 3, 4. 1, 2, 3, 4. There's a 0. I've got 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay? So I've jumped 5/6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. So I now have 4. And 4 more. But that's 4 more out of a possible 5. Now we're going to do that symbolically. Check our work. 4 divided by 5/6. That's like 4 over 1. Same. I'm going to flip it, multiply, flip it back. Flip it. I flip 4 over 1 to 1 over 4. Multiply. Flip it back. My answer is 4/4. I hope this helps. If not, give it another watch or come ask Mr. Ewart for some help.